Hello everyone, my name is Kiran Kumar Sonati. So today we are discussing about our assignment 5, which is about the cyber physical security in industrial IoT. So I have analyzed a couple of articles, and based on my understanding and the knowledge I have gained, I prepared a report. So I am going to present my report to you so that will provide you basic knowledge about that. So I have shared my screen. So as you can see on the screen that about the cyber physical security in IoT industry, in industrial IoT. So first we are getting into the introduction. So when we are tangle the infrastructure and the digital connections are combined, as is the case with the Internet of Things installations, new security issues are arise. Protecting critical infrastructure involving guaranteeing the security, reliability, and availability of the industrial IoT system. In order to analyze the common themes, problems, and also the development in the IoT in the industrial IoT or IoT, cyber physical security, this paper compares approaches and the key technologies, summarizes the key findings then from the research papers. So based on the understanding from the research papers and whatever the findings, you are going to provide the solution for that and propose a theoretical framework to address the recognized issues and enhance efficiency and reliability. So this is all over the interaction. So which tells about how we are going to provide the solution based on the key findings which are given in the research articles. So let's get into the literature review. So first is the integration of IoT and OT systems. Due to the interaction between previous distinct domains, the industrial IoT confused of information technology and operations technology system compliances security management to preserve security and enable effective operations. This integration calls for meticulous coordination. So this is all about the integration of IoT and OT systems. Next, getting into the potential vulnerabilities as attacks. Industry IoT systems are sus- susceptible to a number of threats. As you can see, the industrial IoTs can be very sensitive, which can get attacked with many of the things, including the obsolete software, unsecure communication net connection, and shoddy authentication procedures, safety output, and reputation are seriously at danger from the cyber physical assets, such interfering with the sensor, messing with control systems, or interrupting crucial operations. So this is about the potential vulnerabilities and attacks. So compliance with the legacy system. Many businesses rely on outdated technology, which may not have the recent updates of the built-in security mechanism. Compatibility issues arise when combining the system with the contemporary security solutions. The city is carefully planning to fulfill the security goals. So next, getting into the scaling and l- level of complexity. Industrial IoT implements involving multiple devices, relationships, and running apps running over a broad and complicated infrastructure. So it becomes difficult to manage security at scale. It's this necessitates the use of strong architecture as well as technologies that can cope up with the complexity of linked systems. So next, getting into the key findings, as we can see before that is the literature review. Now we will see the key findings. So first is it to reduce unauthorized access. The study emphasizes the significance of secure authentication of devices and accessibility control. It is suggesting cutting cutting edge technology utilizes blockchain technology to improve security and trusted in industrial IoT system. So using of cutting edge strategy which helps us to protect from the unauthorized access and provide as a protection to the industrial IoT systems. So let's get to the next one. The article concentrated on cyber physical attacks detection methods of industrial IoT system. It offers a machine learning based system that examines sensor data streams in real time, identify anomalous behavior, and initiate the necessary reactions. So, in that one, the use of machine learning and artificial intelligence techniques to secure industrial IoT systems were examined. To counter new threats, it underlines the importance of productive response system, anomaly prediction, and intelligent detection. The seventh one, both the discussion of the value of anatomy discussion. However, presented a blockchain technique for prevent verification while using machine learning methods for detecting anomalies. While large focused on anomaly detection, stressed the blending of AI and machine learning to allow proactive security measures. While focused on this a need for strong and scalable AI algorithms to address the intrusive nature of large-scale industrial system, focused on the acceptance and incorporate the blockchain-based techniques in industrial IoT context. So let's get into the proposed conceptual framework. A conceptual framework is suggested to solve the issues and boost effectiveness and dependability in cyber physical security for industrial Internet of Things. Based on the study of the research article, the framework includes the key components: secure authentication and access control. Implement a strong method for authentication of devices and access control while taking into the account the combination of IT and OT technologies. Utilize the blockchain technologies can improve security and trust. So next is the anomaly recognition and response. Make use of AI and machine learning techniques to quickly identify unusual activity and cyber physical threats. Create proactive reaction strategies to quickly neutralize threats. So next is the connectivity of legacy systems. Create plan and the resource to close the safety breaches between the traditional security measures and legacy systems. This may entail using protocol converters, virtualization, and secure gateway implementation. Scalable security framework. Create a robust, scalable security infrastructure that can handle the complexity and scope of the industrial IoT installation. So, creating of the robust, scalable security infrastructure which can help to do the make the installation easy without any complication of the installation. Utilizing distributed architecture, cloud-based services, and centralized governance of security performance may be necessary for this. These are the proposed framework in the figure one, which is the sensor sensing and the yeah, aggregator, and as the analyzing and decision making by using the programmable logical controller and distributed control system like can be manageable and aggregators. So next is the components and the layers. First is the CPS components, risk levels, and security measures. And figure three, it tells about the security goals. These are the security goals which are used. Security goals, which is confidentiality, integrity, availability, authentication, and privacy. Risk evaluation, the figure four, which tells of the diagram, which has the, how it can be risk mitigation, risk impact, and CPS challenges, risk analysis, and risk assessment. This is the flow, which is actually a flow. So it starts with the risk management, management, risk analysis, CPS challenge, or CPS impact, and risk mitigation. This is risk evaluation, which you are shown here. So when coming into the conclusion part, cyber physical security in industrial IoT presents unique challenges, including the integration of IT and OT systems, vulnerabilities, and attacks. Legacy system compatibility and scalability complexities through the analysis of relevant research papers. This paper has the identified key themes, advances, and challenges in this field. Additionally, conceptual framework has been provided, which is proposed to address the challenges, enhance efficiency and reliability in industrial IoT systems. By adopting a holistic approach and leveraging appropriate technologies, organizations can mitigate risk and framework safeguard critical infrastructure in the era of interconnection, physical and digital systems. So this is the about this assignment, uh, which is about the cyber physical security in industrial IoT. Thank you for providing this opportunity. Thank you.